Modular scout lights. When people say scout lights, they are talking about the industry standard Surefire body design that has the signature tail cap to accept any activation switches and the two mounting screw holes on the side of the body. The tactical advantage is its ecosystem depth. The user can use the same light body with various mounting adapters for either key mod, M-lock, or pick rails. And they can position it on the rail any way they want to basically optimize rail space, or ergonomics. Integrated and proprietary lights. The Inforce weapon-mounted light is the clearest example. It's got the rear-facing non-slip button, safety lever, head rotation lockout, and integrated Picatinny clamp all built into one compact package that installs in seconds. The tactical advantage is snag reduction, and the user doesn't have to deal with pressure switch cable routing along the handguard, or any external connection point that fails under rough handling or rain. But the trade-off is reduced interoperability, because integrated designs typically can't pair with a separate laser device through a shared switch console the way Scout pattern systems can. But way before any of this modern light technology came to the market, they were using incandescent light that people thought was the best back then. And these were the incandescent xenon lights. These lights were the military standard before LED became viable. The core problem was that the battery back then can't support high lumens output, and these designs burned through it so fast that CR123A batteries lasted under an hour. Filaments were fragile enough that a hard recoil event could pop a bulb at the worst possible moment. Also, beam control was poor because reflector designs of that era couldn't concentrate output tightly enough to generate the high candela hotspot, leaving the person trying to see with the worst day of his life on the range, and that it's almost impossible to see anything clearly past 50 meters in the dark. So, in order to graduate from that era of technology, LED white light was the next big thing, and it still is today. By the mid-2000s, LED tactical lights were everywhere, because they solved nearly everything incandescent got wrong in the field. LEDs consume dramatically less power for the same output, and run for hours instead of minutes on the same CR123A batteries, but they aren't as durable to deal with recoil across the firearm recoil spectrum. The color temperature usually sits around 5,000 to 6,500 Kelvin. It's close enough to natural daylight that the human eye resolves detail well at close ranges. For room clearing and close quarters work within 25 meters, a solid white LED gives you everything needed to identify threats and make shoot or no shoot decisions fast. And the output to runtime ratio is vastly better than anything incandescent. High candela turbo LED tactical lights. High candela turbo lights are for long-range positive identification, and the distinction that matters because lumens measure total light output in all directions, but candela measures peak beam intensity at the hot spot, which is the number that actually tells you how hard a beam pushes through haze, smoke, or competing light sources to reach a target. But the marketing you see in public always focuses on just lumen output. So what about lights in the 100,000 candela range? The Surefire 640 Pro and Cloud Defensive Rain 3.0 can deliver usable illumination past about 600 meters, and that intensity is what professionals call photonic barrier penetration, such as aiming at a car with headlight on and still see the target taking cover behind the car, instead of being blinded by the car. While high candela is used for long range, there are also lights made just for close quarter, and they are ones with a decent throw and spill. These lights use optics designed to spill the light broadly rather than concentrating it into a hotspot. And the candela figures look low on any spec sheet. Sometimes most of them are under 20,000, like the Surefire X300 Ultra. Inside a structure, threats appear at 15 meters, and a tight hotspot beam forces constant muzzle repositioning to cover a room while leaving dark corners where someone can stand completely invisible. A flood pattern lights the full width of a hallway, illuminates both the threat and the surrounding environment simultaneously, and reflects off walls in ways that extend effective illumination. For it lacks the throw for a tight hallway or looking down an aisle of a dark warehouse. So now we have high candela lights with a tight focus beam, and we also have something for CQB. But are there something in between? Well, we do. And these are balanced beam lights, and you can usually spot them only if you know how to read the candela and lumen specs to get a ballpark on what the beam profile would be like. Something in the range between 40 and 70,000 candela is a good starting point. These lights sit between flood and turbo extremes, like producing a hot spot with enough candela to reach 400 to 500 meters, while keeping enough peripheral spill to illuminate surrounding areas during indoor movement. And that balance is why designs like the Modular PLH V2 at roughly 54,000 candela with 1,350 lumens, where an expensive Surefire M600 has only 1,000 lumens and only 11,000 candela. The beam pattern gives you enough center intensity for distance identification, while the corona, the ring of softer light surrounding the hotspot, which means it keeps walls, doorways, and immediate threats visible without repositioning the muzzle. For technology like this to work, these lights have graduated to using 18650 or 18350 type battery to give it more runtime and voltage to have a higher output. Laser excited phosphor light. In short, these are called LEP lights that uses a laser diode to excite a phosphor element rather than a conventional LED emitter. And the result is a hyper-focused beam with candela figures that make standard LEDs look primitive. An example would be the Olight Odin Turbo that pushes 275,000 candela past roughly 1,000 meters, with output that experienced users describe as a lightsaber column of light with almost zero peripheral spill, almost like a thick laser beam. However, this design is counterproductive for indoor use because the beam is too narrow and you can't use it for anything else. 850 nanometers infrared illuminators. These are IR light, completely invisible to the naked eye, but clearly visible through night vision devices. Long story short, it uses image intensifier technology to capture the near-infrared light that floods the environment after dark. That near-infrared light, carrying roughly 10 times more energy than what the human eye can see, comes from the same sources as visible light, mainly moonlight and the natural glow of the atmosphere. The image intensifier takes that invisible energy and converts it into a visible image. The tactical advantage is removing the visible white light signature that announces your position from hundreds of meters away. Soldiers use them for aiming, signaling, and aerial crew can also see them for positioning, like signaling for a rocket strike. White and IR vampire combo. The tactical logic here is simplicity. One mounting footprint, one cable run to a remote switch, and one zero to maintain, rather than managing two separate devices fighting for rail space. For example, the Surefire M640V has 350 lumens white light alongside 120 milliwatts of IR at 860 nanometers, with a bezel ring selecting between modes rather than requiring the shooter to swap devices. Early devices like the ANPEC 15 delivered both functions in a single housing and became defining kit for special operations throughout 2 decades of combat in Afghanistan and Iraq. Basically, combining IR light and laser all in one unit. D-Ball class units later expanded on that by integrating a visible laser, and IR illuminator into one rail-mounted housing. Later, the D-Ball A3 added a Class 1 eye-safe IR laser for training alongside the Class 3B operational laser, with a visible green laser for daylight zeroing. What was special operations only for most of the 2000s eventually became standard kit for conventional infantry. In the recent years, MAL-class units took the same concept and refined the form factor, sitting closer to the handguard to reduce the mechanical arm that causes traditional box-shaped devices to shift zero under recoil. The B.E. Myers MAL became the benchmark for modern combined units, largely because of its IR illuminator, which adjusts from a wide flood pattern for close quarters to a tight spot for distance identification in a single unit without swapping hardware. It also introduced ambient light sensing that automatically adjusts IR laser power to maintain safe exposure limits.